you, my digital friends. My name is Claire, and this is the Exweb Show. Let's explore the real technology of the deep web and leave the rest to Slenderman. Here with the tech is our very own unindexed server, Professor Webster.
But on the dark web, we don't want people to know where we are or who we are. So how can we possibly achieve that? How can we create a stealth packet? The most basic tool to access the dark web is Tor. Tor literally stands for the onion router because it uses a layered approach to routing. The more layers, the more privacy. Of course, there are other examples of onion routing out there, but for this video, we'll use Tor as the most well-known. So suppose I want to access a website without revealing the fact that I'm the one accessing it. The Tor network allows me to choose where my connection is coming from. The first thing I need to do is establish what's called a circuit. A circuit is basically a path through the Tor network. Each step on the path knows the IP address of the step in front of it, and it knows the IP address of the step behind it, but not the IP address of every element on the path. Once that circuit is established, my data knows the path to take through the Tor network. To establish the circuit, the first thing I need to do is choose an onion router off the list I got from the directory server. That will be my entry or guard node. It's the only element of the network that knows my IP address, but doesn't know that I'm the source of the data, only that I'm a member of the circuit. The basic unit of communication between routers are called cells, and they're roughly analogous to an Ethernet frame or an IP packet. Every cell has a circuit ID number, either 2 or 4 bytes depending on the protocol version, and a command, which is 1 byte. Newer protocols, version 2 and higher, also have a 2-byte payload length before the variable length payload field. So to let my guard node know that I'm on this circuit, I send it a create cell. My create cell basically just tells my guard node that I'm creating a new circuit and I would like it to know about it. It has a circuit ID number that's on the create cell, and the create cell also has some decryption key information for it to be using whenever it communicates over that circuit. Let's say I create circuit number 1. I send the create cell to my guard node, and it sends me back a created cell, acknowledging that it now knows about the circuit that I've created. Next, I choose another node off my list from the directory server. That will be my middle node. I send a new cell to my guard router, this time with the extend command. The extend cell has a link specifier on it, which for our purposes is the IP address and TCP port number of the middle node. It tells our guard node to send a create cell message to the middle node, and to give the middle node a security key we've already encrypted with the middle node's public key. From now on, any message the guard node receives addressed to this circuit will be sent on to our middle node. Now we go through that whole process again, but this time we tell our middle node to extend to a third node, our exit node. This last node is the one that will actually open a TCP connection to the target website and give us back the information we want. Now we've established the circuit. Because each time we extended the circuit, we gave each new node its own key, that means the guard node and the middle node can't read the traffic that we're sending to the exit node. The next step is to tell the exit node to open a new stream. A stream is essentially just a TCP connection. So I send the exit node a relay packet with the subcommand begin relay and the IP address and the TCP port of the system I want to connect to. The exit node sends back a relay connected or relay end response depending on if it was successful opening the connection. If the connection is opened successfully, the exit node and I start sending relay data packets back and forth, which contain the actual inbound and outbound information flowing over the TCP connection. When I'm done, I send a relay end command to the exit node. If I'm finished with this circuit entirely, I can send a destroy cell to my guard node, and it will propagate the cell to all other circuit members, who deallocate the resources that they had keeping that circuit open. The key thing to notice here is that while my guard node knew my IP address, it didn't know whether I was the originator of the circuit or just somebody else's guard node. The middle node only knew the guard node and the exit node's IP addresses, but it didn't know if the node before it was the guard node or the originator. The exit node only knew the middle node's IP address and the final connection IP address. If I were sending unencrypted information, the exit node could also read what I was sending to the final destination on the public internet. Thus, nobody in the chain knows both that I was the original requester and what my IP address is, except for me. Now there's a lot more depth to cover here. Why can we only send TCP traffic over a Tor? Why can't we send all IP traffic? How do we look up host names? How do hidden services work anyways? All excellent questions. If you're interested in the answers to those, leave a comment below and we'll revisit it in a future episode.
Farewell from the electronic universe. I've been your guide, Claire, and we hope you'll come exploring with us again soon on the Exweb Show. If you have questions or suggestions for future videos, leave a comment below or check us out on Facebook and Twitter.